the Cyrene Automotive Pilot Demonstration hosted by Centro Ricerche Fiat. So welcome to everyone. My name is Giulio Vivo, and you are quite numerous today as we expected. So just for the guests who are not familiar about us, let me just spend a couple of words about Centro Ricerche Fiat, who is hosting this Cyrene Automotive Pilot Demonstration. And the CRF headquarters are in Orbassano, Turin, and we have the specific mission to contribute to the research and development automotive manufacturing activities and services of the Stellantis group. And in the context of the Cyrene Horizon 2020 European project, CRF is representing one of the end users and specifically the automotive manufacturing industry. And in this applicative demonstration that you are going to see, we participate directly into the vehicle transport system, which is a structured and complex supply chain service which is containing numerous players, this supply chain service, starting from the assembly and manufacturing of vehicles upon the handling of the supplier's order requests and ending with the actual shipment and delivery of the assembled vehicles to the end customer. So let me leave the floor to Sophocles Ephremidis, who is our project coordinator.
Okay, so good morning from my side as well. Thank you for your participation to this event of the Cyrene project. As Giulio mentioned before, so this event is planned to demonstrate the major outcomes, one of the major outcomes of the project. So we plan to have an overview of the project itself, and then we will go into the details, not very many technical details, but enough, right, to have the follow-up demonstration. We do have, all right, some issues. All right, so my name is Sophocles Ephremidis from Maggioli, the project coordinator of the Cyrene project. So I'm going to spend the next 10-15 minutes to give the overview of the project, its major achievements, and how we reached to the point of having today's demonstration that we have planned, right, and scheduled as a major outcome of the project. So Cyrene is a project, well, the acronym itself is certifying the security and resilience of supply chain services. And by its very name, the project, it becomes evident that the project focus is on supply chain services. And in particular, the cybersecurity, security and resilience issues, aspects of those services. So a few things about the project itself. So the project is a 3-year project. It started October 1st, 2020. It runs for 36 months and it is going to come to its end this September, end of September 2023. We have a little bit less than 3.5 months to go. So the major developments of the project are by now complete, and we are in the phase of exercising those outputs in the context of project trials. So Cyrene is a research and innovation action type of project. There are 14 partners from 10 different countries across Europe, and we have a good mix of partners that come from industry, from research and academia, and also small and medium enterprises with complementary expertise that have been brought to the project. So the target of the focus of Cyrene, as I mentioned before, is on supply chain services, which are complex ecosystems comprising organizations, people, activities, information, and resources, which are all work together and are involved in the supplying of a product or a service to the consumer. Why supply chain services? Because their importance cannot be overstated. They are enablers of global trade, global economy, everything that moves around the world. There is a supply chain behind it. And then disruptions also of supply chain services may have a heavy impact, political, economical, social, and so on. So it becomes very important to take a look into those services and try to somehow certify the smooth operation, which their smooth operation, which means certify their security qualities, resilience qualities, and so on. And then a number of sectors, right, can be evidence, right, where supply chain services operate. So, for example, health, food, energy, manufacturing, software, and so on. So what's the motivation behind the project? It has been identified that there is a lack of structured and standardized way to forecast, prevent, and manage interrelated and propagated cybersecurity vulnerabilities and threats, while at the same time taking into account the complexity and heterogeneity of supply chains and supply chain services. So this lack of a structured way to guarantee security and resilience qualities, coupled with the need of methodologies and techniques, tools as well for the efficient evaluation and handling of security threats, is the motivation behind Cyrene. So Cyrene comes to fulfill those needs and provide process and technologies and tools to certify the compliance, assurance and compliance of supply chain services as far as security and resilience is concerned. So what's the influence behind Cyrene? So Cyrene actually comes at the right time as far as international initiatives, in particular European initiatives that have been put up. For example, the Network Information Security Directive, NIS 2, which calls for a high common level of cybersecurity assurance across member states. The Cybersecurity Act that establishes a cybersecurity certification framework for products and services, and also the Cybersecurity Resilience Act. So these are initiatives taken by the European Commission with the focus on cybersecurity assurance of ICT infrastructures. And at this time, when those initiatives have been put up, Cyrene also was brought into life, and at the end, the project trials and justifies, implements to some extent some of those initiatives. The project also has been influenced by other international standards, for example, the ISO 27K, 28K, common criteria, and so on. So what is the outcome of the project? Supply chain services are treated as targets of evaluation, and these services are viewed in three different levels of abstraction: in supply chain business processes, the high-level interactions between participating stakeholders in a supply chain, at the level of infrastructures, interdependent infrastructures, interconnected, heterogeneous as well, supported by information communication services, and also spanning multiple administrative domains. And the third level is the level of assets, which are components and devices that support the infrastructures that are operated by supply chain stakeholders. Moreover, there are three different viewpoints of supply chain services: the business viewpoint, the technical viewpoint, and the sector-specific viewpoint. So in this complex environment, the project outputs a certification scheme which is compliant to international standards. In particular, it is an extension of the ENISA EUCC. A risk and conformity assessment process, a set of tools and a platform that supports the methodology, the risk and conformity assessment methodology, and also best practices that have distill the result of applying the tools and the methodology into the two pilot projects, one of which we will demonstrate today. So the outcome of the project is this structured approach and also a toolset for the certification of supply chain services, which is based on international standards, a certification scheme as an extension of the ENISA EUCC, and a dual-use certification assessment process, which can be used either by individual stakeholders for the self-assessment of their supply chain part, and also by third-party assessors to certify the conformity of a supply chain service to given requirements. So this process and certification scheme is coupled and supported by a platform and a tool set that has been developed in the context of the project. So the risk and conformity assessment methodology is a structured way. It comprises a number of rigorous steps that start from the analysis of the supply chain service and go all the way to its certification. So details of the methodology, we will present it in the following presentation. And as I stated before, behind the whole work of the project is a number of international standards on which the project builds. The ISO 248K, 27K, the ENISA cybersecurity certification, and then, of course, take into account the EU Cybersecurity Act, Resilience Act, and so on. So the project by now has completed all of its technical work. The certification scheme for supply chain services is was ready by the first year. Same for the conformance and risk assessment process for supply chain services. And once this the certification scheme and the process have been defined, then it went into the phase of developing tools and platform in support of those of the methodology. Currently, the platform is exercised and the methodology is exercised in the second of the two pilots foreseen in the project, the CRF pilot, in which we will focus the rest of the presentation today. Further to this, the project runs a number of open call external projects that either provide extensions to the platform that has been developed in Cyrene and also exercise its methodology and tools in new domains, right? In addition to those that are used for the internal project trials. So I guess this is an overview of the project from my side. We will continue with the presentation of the methodology and then the demonstration of how it is applied to the CRF pilot case in the project. So thank you from my side. I guess the floor goes to Ms. Kalogeraki for the presentation of the methodology.
Thank you, Sophocles and Giulio. So this is Lena Maria Kalogeraki from Maggioli, and I'm going to present to you the Cyrene Risk and Conformity Assessment Methodology. So please let me share my screen first. So can you see my screen?
Yes. Yes.
Okay. So Before starting to present the Cyrene's RCA methodology, I'd like to, at first, to chat a little bit concerning the cybersecurity standardization certification. Why do we need cybersecurity standards? Cybersecurity standards are able to guide us on sufficient security management, and also allow us to evaluate the effectiveness and strengths of security management of an organization or further entities such as supply chain service. So here, as Sophocles said, the under examination object is supply chain service. So cybersecurity standards can increase the resilience of supply chain service. They bring innovation, spread knowledge, and increase cybersecurity preparedness. The formal attestation to confirm that the supply chain service meets all security requirements addressed by security standards is given by cybersecurity certification. Cybersecurity certification can improve the level of security and the competitiveness and the resilience of market, and can empower confidence. It can also address market fragmentation. Concerning cybersecurity and certification schema, it resides with the conformity assessment process, which demonstrates that specified requirements are fulfilled. So certification scheme is considered a conformity assessment system related to management system to which specified requirements, specific rules and procedures apply. A prominent cybersecurity certification scheme is currently the European Cybersecurity Certification Scheme, EUCC, developed by ENISA. Main elements of a scheme can be an evaluation process and subjects requirements. Until now, we don't have a specific certification scheme that addresses supply chain service cybersecurity aspects. Therefore, Cyrene project has developed and proposed a cybersecurity certification scheme for supply chain services, and the Cyrene RCA methodology complements this scheme by developing an evaluation mechanism to assess the security of supply chain services. So you can see it changing my slides, correct?
Yes, Alba.
Yes.
Okay.
Yes.
So Cyrene RCA methodology is based on an extended security model which provides an interplay between risk and conformity assessment concepts. In this diagram, we can see at the above part of the diagram some information security concepts related to ISO 27000 for information security. And at below part of the diagram, we can see conformity assessment concept related to ISO 15408, namely the common criteria, related to conformity concepts, and also for 18045 ISO, related to IT evaluation criteria. So the Cyrene RCA methodology has a dual, provides an evaluation mechanisms for supply chain services, which has a dual use. From one side, to conduct a risk assessment, to allow business partner conduct a risk assessment upon supply chain service assets, to identify risks, undertake proper mitigation controls, and create a protection profile, which we can see later on that it is a set of security requirements and assurance requirements. And from the other side, to allow auditors to review the protection profile developed by business partners and assess the claims of the profile and see if the supply chain service meets cybersecurity certification scheme requirements. So the legal background and standards for Cyrene RCA methodology are several. We have concerning ISO ISO 28000 for supply chain security management. We have considered ISO 27000 on information security. We have conformity aspects of ISO 15408, that is the common criteria, IT evaluation criteria of ISO 18045. We have also considered the common vulnerability score system of first version 3.1 for our vulnerability analysis. We have considered NIS2 directive to identify the criticality of a supply chain service. And we are based on HTVRA methodology, and also we are based on the certification schemas ideas to illustrate the Cyrene cybersecurity certification scheme for supply chain services, namely the Cybersecurity Act and the EUCC, as said before. So, as we said, the Cyrene RCA methodology complements the Cyrene proposed scheme. We have three main objectives: assess and manage the risk of supply chain services, prepare the protection profile, and from the other side, to assess the claims of the protection profile by auditors. So we have three main roles: the supply chain service provider, which is the representative of the supply chain service, the one who initiates the assessment. We have the business partners interacting with the supply chain service provider for implementing respective processes. And we have also the auditor who audits the overall process and conducts the conformity assessment. So Cyrene outcomes are an overall report of the assessment results and risk treatment. And the auditor then will review this report together with the protection profile, which will be developed collaboratively by business partners to assess the claims and to see if the supply chain service meets cybersecurity certification. And if so, he then will issue a certificate. So here we can see all the steps of the Cyrene RCA methodology. We have 6 high-level steps, which we are going to present in brief at next. So the first step is the assessment scope, which is the boundary setting. Before starting conducting the assessment, all business partners involved in the supply chain service will mutually sign a security declaration application statement, which is an agreement upon all business partners upon privacy and security considerations and their engagement to provide all relevant security information of their organizations, and that they will also undertake proper controls after the assessment. So the basic components of the SDA is at first to identify what will be the target of evaluation. Here is the supply chain service, and you can see that in our scenario, we have the vehicle transport service. So in CRF Pilot, you're going to see evaluation upon inbound logistics of automotive components, processes, and assets specifically. So we have also to identify the supply chain service provider, who will be the representative. Here in our current pilot is CRF, the automotive manufacturer. The assessment scope, here we have a risk assessment conducted by all business partners and following, of course, the Cyrene cybersecurity certification scheme. And we have to also to define which evaluation view will be followed. Sophocles introduced to you before what are the evaluation views. Overall business is related to business aspects assessment. Holistic technical engages all relevant processes and assets participating in the supply chain service, whereas sector-specific are only refer to sectorial processes and assets of a specific business partner that participates in the supply chain service. So here we have the automotive manufacturer, CRF plays that role, and we are going to test only sector-specific process and assets. Also, we have to identify the supply chain service criticality upon an assurance scale that was developed by the Cyrene methodology, which relies on NIS2 directive. And this assurance scale, as you can see, sets also some conformity assessment characteristics, such as the assurance level to be followed, the vulnerability analysis depth, which relies on AVA1 assurance class of common criteria, and the attack potential, namely the attacker's effort to launch an attack, considering three main parameters: the attacker's motivation, the attacker's sources, and the attacker's expertise. So by adapting a specific level of attack potential, we mean that after this assessment and the controls that will be undertaken, the supply chain service will be resistant to attacks towards this attack potential, toward this attacker's effort. So in the next step, we have the supply chain service analysis. Here we identify the supply chain service components, which are the processes executing for the provision of the supply chain service and all relevant assets operating, together with business partners interacting to execute these processes. So we identify here business models and asset models, and we identify also dependencies between two assets of different business partners interoperating, which call them cyber dependencies. In this step, we also estimate the criticality of supply chain processes and assets according to specific rules. For example, for supply chain service process, we have one rule related to if the loss of integrity or availability or confidentiality of the process affects the overall provision of the supply chain service. And we have another rule related to if the process has a specific backup plan or a continuity plan. We have also asset criticality rules that inherit the supply chain, the assets inherit the supply chain service criticality level of processes. And we have some other rules related to complexity, confidentiality, again, integrity and availability, backup processes, and so on for the assets. So our next step will be the threat analysis, threat assessment. In Cyrene, we identify threats on assets by consulting knowledge threat repositories such as Mitre, and we identify a set of threats and common weakness enumeration IDs for under examination assets. We also then assess the threats to identify a threat level, considering the threat frequency of appearance. Our next step will be the vulnerability and impact analysis. In this step, we do a lot of background processes, such as to translate the attack potential level into a numeric score according to the Cyrene probability scale. You can see the next table. We have to identify confirm vulnerabilities based on online repositories such as NIST vulnerability database, and also consider some vulnerability metrics of CVSS 3.1 specification first, identify unknown vulnerabilities as well, and evidence-based vulnerability analysis. For this, to illustrate Cyrene capabilities concerning intrusion detection mechanisms and anomaly detection, we have identified a cyber attack scenario you will see later on through our pilot execution to illustrate Cyrene capabilities on these aspects. Also, we estimate the individual vulnerability exploitability, and we develop vulnerability chains, which are potential attack paths, and estimate the attack path exploitability. So we can see here quickly the vulnerability exploitability calculation per asset. At first, we identify metrics of CVSS 3.1, which has three main groups: base, temporal, and environmental group. Base are constant values. Temporal and environmental group are values that Cyrene addresses in a specific manner. Concerning temporal group, they are filled by business partners according to their needs, to the specific supply chain service environment needs. And concerning the environmental metric group, some metrics are filled by supply chain service business partner, and some other metrics are automatically calculated considering the assets identified criticality. Also, concerning the individual vulnerability exploitability estimation, we see here that we have we have some metrics of CVSS 3.1 environmental group that are considered along with the attack potential to identify the vulnerability exploitability per asset. So after we have calculated the vulnerability exploitability per asset, we need to identify the vulnerability the vulnerability exploitability per a set of sequential vulnerabilities. Let us say vulnerability chain. Namely, vulnerability chain can be considered all the attack paths, alternative paths, by a specific asset that allows the attacker to access the supply chain service network to reach a specific targeted asset. So we follow some relevant calculations, and we generate attack graphs and identify the exploitability among all interconnected nodes. So our next steps is the risk assessment. We follow the basic risk equation, the multiplication of threat level, vulnerability level, and impact level. But here in Cyrene, we add also the attack potential parameter, and the vulnerability and impact level is considered the vulnerability severity level, which is the score that derives from the CVSS 3.1 calculation after completing the Cyrene consideration in the environmental group. So here we have the Cyrene probability scale, and after calculating the risk, we can set numeric values according to our results. Our final steps are risk compliant mitigation. These steps are to identify mitigation strategies after conducting the assessment and reaching the assessment results. So business partners in that step, they can conduct a cost-benefit analysis to the entire supply chain service, and also identify a set of security requirements to develop the protection profile. Then they have to assess the risk level estimates defined in the previous steps against the set of the identified security requirements that are within the protection profile. So this list of measures undertaken, they are focusing on risk compliance with these security requirements. As a final step, upon alternative security strategy, mitigation strategies, a set of controls, we identify optimal security controls to implement upon our assets. Then we develop security reports. The Cyrene platform creates the Cyrene overall report, including all assessment results and privacy and security considerations. And then the auditor can use this report along with the developed protection profile, to assess, implement, and control strength in treating the risks to meet the security requirements of this protection profile and investigate if the supply chain service covers the requirements set by cybersecurity certification scheme. So in the following, you are going to see the CRF pilot. This pilot has as main objectives to demonstrate the application of this Cyrene RCA methodology to the Cyrene platform and also showcase the Cyrene platform conformance and capabilities, which are IDS capabilities, anomaly detection analysis, dynamic vulnerability analysis, and of course, risk and conformity assessment capabilities. So in this pilot, we aim to test and validate the Cyrene platform under real conditions and allow CRF pilot and users to provide us fruitful feedback after experiencing Cyrene platform, which will be considered in the technical development process of the Cyrene platform until the end of the project. So this is my presentation. Thank you very much.
Okay, Elma, thanks a lot for your presentation. It is really crucial to have an idea, precise idea, and thanks for explaining it about the RCA methodology. I will leave the floor to Sofia Karagiorgu, which is our Cyrene technical manager. Welcome, Sofia, and to explain the Cyrene platform. The floor is yours, Sofia.
Good morning from my side too, and welcome in this CRF pilot. I will give you the technical background of how this risk and conformity assessment methodology has been technically implemented and facilitates different services through the Cyrene platform. We have taken into account very technical details by means of identifying ICT assets and upgrading onto the sectorial, which is the part of today's pilot. We also enrich with metadata business processes that are part of this inbound automotive manufacturing logistics. This is a specific view of this pilot when being part of business processes interconnected within a supply chain service. We also investigate exposed APIs as part of interconnected business processes across different organizations and different partners. So we have several threat scenarios. You will see more details later regarding the sectorial battery management of this inbound logistic service. But within Cyrene, we also have taken into account an end-to-end supply chain service by means of vehicle transport services, introducing ports, introducing the automotive factor and different distributed services that are exposed as part of this supply chain service. Also, in order to define the specifications, we collected requirements both from the end users, namely the CRF end user, but also part of the port. We have taken into account the three different views of the targets of evaluation from the ICT, the devices domain, the business processes and the supply chain services. But today we will focus on the sectorial aspects, bringing into action ICT assets that are being monitored and participate in business processes as part of this inbound logistics scenario. At the same time, we have taken into account the European certification scheme. We have modeled in the background via the Cyrene ontology all the required knowledge in order to build ICT assets, threats, vulnerabilities within a coherent ontology. And later I will present you how this RCA methodology is being instantiated via the different technical layers of the architecture, and I will give you a short overview of the platform itself. So here I would briefly like to draw your attention in different aspects instantiated in this pilot through the Cyrene architecture. So later on you will see both from my high-level view, but also in the pilot that will proceed, different functionalities as part of this abstracted architecture. So we have enabled certification services as part of the security layer. We have also enabled, as part of threat and vulnerability assessment, different aspects of these vertical layers, including detection of real-time events, monitoring and reporting back regarding findings, threat detection, including detection and prevention, but also anomaly detection and reporting, simulation and prediction of all possible attack paths, taking into account a specified source and destination node within these interconnected systems, but also event captors capturing the breach of confidentiality, availability and integrity of the underlying system of this inbound logistics that produce more evidence and facilitate the risk calculation. On the other part of this instantiation, you will also see later on a scenario instantiating risk assessment incorporating different business processes for the CRF, but also enforcing controls and firstly quantifying this risk, but also taking mitigation actions and enforcing controls, recalculating the risk and quantifying how these actions have effect to mitigating, decreasing and controlling the risk. Everything has been integrated in a dashboard that I will right now present you how everything has been materialized via a platform starting from the security and the authentication mechanisms. And I will briefly go through simply to introduce you the tools that are currently supported, and I will later leave the floor to the real demo to present the specificities of this inbound logistics. So as you see, I'm accessing the core Cyrene dashboard, providing some high-level capabilities. Here, by selecting the organization, I can see instances being part of this organization, namely the CRF organization. And I can navigate as end user, getting access to different services such as the supply chain management, letting the end user model its own assets, adding metadata regarding the business processes that these assets are participating, and agreeing on the business processes that are exposed to other organizations as an overall supply chain service. Before setting the whole methodology, participating partners need to agree and proceed with some security declarations on the assets that are being exposed, but also on the exposed APIs as part of cyber dependencies, not only affecting internally an organization, but also affecting the participating organization as part of this extended supply chain service. We have also functionalities regarding the asset inventory, so the end user can populate assets, and we have also the supporting mechanisms in order to align these ICT assets with some common platform enumeration, but also with the common vulnerabilities. And we have also the controls that are enforced on top of the assets and are part of the measures that we can take in order to mitigate, decrease and control the risk. Part of the threat intelligence, we have the automatic processes that link daily the platform, the Cyrene platform, with open repositories, including vulnerabilities, weaknesses and threats. And last but not least, we have the set of steps in the step of tools in the support of mainly step 3, how I can quantify, detect and report on intrusion detection, on anomaly detection, and you will see more details later on the anomalies that we detect and how they are prevented via the intrusion prevention tool, but also part of the vulnerability assessment that performs dynamic vulnerability with active and passive scanning, and reports about the breach of confidentiality, integrity, availability of the underlying platform. And this brings me to the end of this overview. Most of these instances will be demonstrated later on as part of this CRF pilot, but I would simply like to draw your attention on 3-4 core tools that would be part of this demo, which is the modeling of the supply chain and the definition of the cyber dependencies, the threat detection, the vulnerability assessment, the calculation of the risk, and when enforcing the controls, the mitigation of the risk, decreasing the risk, and providing the overall overview of the calculation as part of the report for further analysis, either for the participating entity or to be disseminated in third parties such as auditors, etc., etc. And now I will stop sharing my screen, and I will give the floor to my colleague Giulio to give you all the background info regarding this pilot and how this pilot has instantiated the different aspects of inbound logistics on behalf of CRF.
Okay, thank you, Sofia. Thanks a lot. And let me give this description actually of the CRF factory pilot. Let me share my screen, and okay, it should be this one. Okay, this is the presentation, and basically the objective of the CRF pilot is to allow end users of the automotive manufacturing industry of this sector to test and validate the Cyrene platform capabilities under actual operational conditions into a real scenario. And as mentioned, The current pilot scenario focuses on the assessment of the sectorial processes assets to identify possible risks, vulnerability, and threats, sustaining the undertaking of proper countermeasures to safeguard these assets and tackle the potential of risk propagation throughout the entire vehicle transport service network. And as you see, to this purpose, CRF will use the Cyrene platform to conduct a sector-specific risk assessment on the processes and assets related to the inbound logistics, considering the cyber dependencies with interoperating assets of these sectorial partners, and to showcase the vulnerability analysis capabilities of the Cyrene platform. During the pilot execution, we'll play a cyber attack scenario upon CRF ICT assets supporting the inbound logistic processes, as we are going to see. Into this picture, you see some part of the inbound logistic activities. There are, as mentioned, some IoT devices, some data loggers that are used to track and to monitor the localization and the quality of some delicate components that are the batteries of the transport batteries of the electric vehicles. It is the Fiat 500 electric vehicle into our specific case, and these data loggers allows to monitor the localization and the quality of the components transported from the production site, which is the site, the plant of the supplier, which is Samsung SDI in Hungary. It is this plant, and the delivery happens along the Europe up to the actual production site where these batteries are assembled into the Stellantis production plant of Mirafiori in Turin. And these IoT devices are installed on dedicated holders. You see there is a carrier, individual carrier for each one of the battery that are then stored and packed into these trucks, and these green containers, and they include some sensors and some electronics. These data loggers, allowing and enabling indeed the GPS localization and the detection of other relevant parameters such as the temperature, the mechanical shocks, the vibration, the exposure to the magnetic fields. So it is including also these EMC factors. And thanks to the near real-time data about quality condition and geolocalization of this material during the shipment, the supply chain management can update information about the time of the delivery of these batteries, and which is the estimated time of arrival, the ETA we call it, and most important, it is possible to assess the quality of the delivery along the supply chain, and in this way the assembly plant is able to schedule and or reschedule if needed the whole production, let's say. And okay, here let me just go quick on that. There are some nice pictures of people who is involved to carry out the current installation. You see of these data loggers on the carriers on these racks, And so just let's provide a few more slides about the pilot components. And overall there are how to say two major activities that we would like to point out in our pilot. One activity is related to the supply chain management that is carried out actually by the IoT and cloud component in the architecture, and the other are related to the actual vehicle assembly plant operation, as we will see in the next slides. So you may see the same concept into this layered representation, where the upper three layers are deal with the cloud and the IoT part of our components and architecture, while the bottom layer is deployed actually as a physical hardware and component in the quality inspection and the assembly workstation on the premises within the Mirafiori plant. Okay. This slide, I don't want to provide how to say too deep technical detailing, but how to say it integrates somehow what already introduced by Sofia as a technical deepening, how to say. Okay, this slide is showing this concept and repartition in two parts of our pilot. And let me just use it to highlight once more that the Cyrene components that you will see in operation during the factory pilot execution session that will start in a few minutes, they include this part on the right side, where you see these IoT devices. They are communicating by means of narrowband IoT and other backup protocols with the logistic server, which is this logistic server is just a virtual machine running on the premises of the mobile operator, who is an external service provider supporting this function in the architecture. There is a MySQL database deployed into this machine, ensuring the data persistence for the collected information at this edge level, how to say. And you see here the Cyrene platform, which is deployed in another virtual machine in the cloud of NPO, which is a Stellantis partner who is providing services and assistance in our work in Cyrene. And by the way, let me take this to introduce some these components and their acronym. BACS is one of the components of the Cyrene architecture, which is deployed at this level of the cloud. BACS is the behavioral analysis and cognitive security. Okay, and the Cyrene platform itself is connected via VPN tunneling to the first of these servers in the Cyrene actual premises, which is this machine here. And VAP stands for vehicle assembly process. And this server, we call it machine 1, is a Linux front end whose main purpose is the data ingestion from the cloud infrastructure and the persistent storage in a MongoDB database, which is this machine also hosting two other fundamental components that we'll see into the execution session. One is Everest, which is the event reasoning toolkit, and the other is DVATS, which is the dynamic vulnerability assessment and testing service. You see, furthermore, and finally, in this CRF premises, there are two other servers. We call them machine 2 with little fantasy, I have to say, but we gave these names, machine 2 and machine 3, and they are carrying out, how to say, the functions that are indeed really important of the quality inspection and the final assembly, respectively, in our architecture, and these assets are all connected into the same network, as you can see by means of this Ethernet switch. And they are connected together with this last Cyrene component that we see here in this representation, which is the IDS IPS, which is the intrusion detection, intrusion prevention system. It is based on some nice electronic with the field programmable gate array of FPGA. Component, and it is absolutely compact but extremely powerful due to the characteristic of this deployment. Okay, let me move on. So we took too much time to give this technical detailing. Okay, just few words about our threat scenario. I took the freedom to report to you this how to say slide just as an historical let's say to make the point about how we arrived to the definition of our scenario into the automotive supply chain services, and we tried since the beginning of the Cyrene project to define a demonstrative scenario as simpler as possible in order to demonstrate the full functionalities of the Cyrene platform, but at the same time trying to avoid all unnecessary detailing and repetitions, also in the light of the already significant demonstration that has been already carried out on last February 2023 in Valencia, during the first Cyrene pilot demonstration event hosted by the Valencia Port Foundation Authority, and so as you see, different ideas, different possibilities, different concepts were discussed and proposed, such as a physical. All of them are how to say mimicking, so they are simulated, of course. As you can see, these ideas consist on a physical terrorist attack to the containers management supply chain services. Another possibility was a cyber attack based on phishing to the vehicle component transport supply chain services, or even lastly, and even a more specific and technically precise supply chain attack to the ICT infrastructures of the pilot. But at the end, what we all agreed to as a description of our scenario is what you see here, which is quite simple and at the same time almost how to say realistic and easy to describe and to understand. And that at the end, at the same time, it is sufficiently, how to say, elaborated and affecting the different assets of our supply chain services. Let me just read that one malicious internal employee he got fired from the company, and still this employee holds some valid access credential to the asset of the Fiat 500 electric vehicle battery supply chain, and this malicious employee intends to get revenge, and by causing some damages to the organization into two distinct ways. So by physical damaging some batteries, and by accessing, how to say, to the warehouse where these batteries are stored, and the second way is through the interruption of some supply chain management services related to the delivery process of these sensitive components. As we have seen, let me say it again, the logistics of these components includes IoT data loggers and cloud services, and the internal delivery of this battery along the quality check and the assembly workstation of the vehicle production line. So the steps of the execution flow of our attack scenario, as you will see in a few moments in the execution phase, it consists in the access to the electrical vehicle batteries Stellantis warehouse, and in the short circuiting of some of these batteries. And here, as soon as this scene happens, the IoT data loggers that are installed on the battery containers, they sense the thermal runaway of these delicate components, and BACs detect these anomalies based on deep learning and machine learning algorithms. And the next scene afterwards, these malicious employees logs in one of the servers, which is the machine 2, as we have seen in our architecture, of which he still holds access credentials. And here he intended to carry out various disruptive activities, starting from the intrusion into the main Linux front-end server. And as soon as he carry out this intrusion from the machine 2 into the main front-end Linux server, the IDS FPGA component, the IDS IPS components of the Cyrene platform detects this attempt and this actual intrusion. It detects this access by triggering a specific IP rule carried out by this IDS FPGA component. And after intruding in the main Linux front-end servers, this cyber criminal, he now stops some crucial supply chain management services running on this machine, such as the functions of the MongoDB server. And as we will see during the execution, a monitoring rule has been created and deployed in the pilot to check the status of any specific instance of a MongoDB service. So Everest, which is the event reasoning toolkit in the Cyrene platform, Everest detects this interruption of the database service. And finally, the DVATS components, as we will see, that is the dynamic vulnerability assessment and testing service. DVATS detect analyze and assesses these vulnerabilities in the ICT infrastructure of our factory pilot, and this is carried out by means of two distinct vulnerability detection methods. Let's say there is a passive network-based approach and an active host-based approach, as we will see in a short. But what is more important, it was how to say relevant to repeat and to how to say to describe with some detailing this threat scenario that we are implementing. But as already said, even in the invitation letters, emails that we have sent all around. So since the beginning, I said, during the execution of this threat scenario, we want to deal specifically with the detailing and the specificities of the cyber attack, and neither we will how to say describe deeply on the countermeasures of the cyber resilience. The focus will be kept mostly on the application of the RCA, the risk and conformity assessment methodology that has been developed and as a comprehensive achievement in the Cyrene project, and as it was presented by Elma just a few minutes ago. So this is my last slide as in introduction, and if you agree, we move to the execution. I would how to say stop my sharing. Okay, thank you. And I would leave the floor to my colleague Petros from UBI, so our colleague, and to start the actual execution of the pilot. So we start by describing the boundary setting, and before conducting the risk assessment in the Cyrene platform, the automotive manufacturing sectorial partners that will be involved in the assessment of the vehicle transport service consent to a security declaration and application statement. And this is to identify the target of the evaluation and agree upon specific terms, conditions, conformity claims, security and privacy considerations of the evaluation process, and declare their commitment to undertaking appropriate controls as explained during the presentation of the Cyrene risk and conformity assessment methodology. And okay, and the security declaration and application is initiated by the entity who seek for assessment, which is CRF in the current scenario, considered as the supply chain service provider, who is the main actor of the risk assessment performance. So we carry out the login. Okay, another attempt. Okay, we actually carry out this login, and after logging in the Cyrene platform, to initiate a security declaration and application, all the relevant fields, as you see, must be filled, such as the supply chain service with a short description, right? And the supply chain service criticality, right, from this drop-down menu. And by selecting the supply chain service criticality, assessment characteristics are automatically selected as shown according to the Cyrene risk and conformity assessment methodology, and namely the assurance level that will be adopted for the assessment, in this case substantial, you see, and the level of the attack potential, which is basic, as you see, and the level of the vulnerability analysis that will be conducted on the assets under examination, which is in our case AVA Van 2. Thank you, Petrus. So in addition, we define the evaluation view of the supply chain service assessment, which is sector specific in our current case. And this means that this evaluation we will assess that in this evaluation we assess only sectorial processes and assets related to the automotive inbound logistics and operating in the vehicle transport supply chain service. Once the security declaration and application fields are filled and agreed among all involved partners, yes, the security declaration and application is submitted and accomplished. Okay. As a next step, as you can see, we have the supply chain service analysis, exactly. And so after submitting this security declaration and application, the Cyrene platform creates a supply chain service along with the metadata provided in the previous step. And the end user can see the automotive manufacturing sectorial processes that exist on the interconnected supply chain service and its objectives, and the attack potential, which will be used later on by the cyber risk assessment calculation. As you see in the fields of the overall objectives, security objectives, and requirement. Yes, we are seeing, and it is important. Yes. Thank you, Petrus. It is important to mention that in the background, the Cyrene platform calculates the process and the asset criticality score based on the worst case scenario, which happens when there isn't any backup plan. Okay, let's remember this, because this condition will change, and then it will affect the assets vulnerabilities environmental score in the next steps. Okay. Also, the supply chain service business partners are able to visualize their asset inventory or edit the asset metadata, as we have seen, and we have set a common platform enumeration for most of the assets in order to combine the assets with the vulnerabilities during the threat analysis step. And yes, in addition, the Cyrene platform consider the interaction between the different business partners of the supply chain service involved for the execution of the processes. And this means that the supply chain service provider exposes some assets on the web to interoperate with other business partners and their assets to send and receive information for the execution of processes. And in the context of Cyrene, we call these business partners interaction points as cyber dependencies. Yes, as you can see. And all business partners who agreed through the security declaration and application to participate in the current assessment, they must accept the interaction to allow their asset to be evaluated by Cyrene during the assessment performance. And afterwards, we have the threats and vulnerability identification. Yes, thank you, Petros. And here, let's say that the Cyrene platform is 100% compatible with NIST and CAPEC data sources. And then basically on a weekly basis, Cyrene collects data from the open APIs provided by third-party organizations and updates the vulnerability knowledge repository according to NIST vulnerability database. And so we collect these vulnerabilities information according to the CVSS 3.1 specification, which is a core concept to calculate later on the exploitability of the vulnerabilities per asset in the Cyrene platform, following the Cyrene RCA methodology. And users are able to see the vulnerabilities for each asset that has a common platform enumeration name. And also there are threats, also known as attack patterns in the CAPEC ontology that present possible attacks such as SQL injection. Okay, as we see. And the attack potential is considered in the risk assessment calculations as shown in the next steps. Okay, so the next, as we see in a moment, yes, it is no. Yes, it is the anomaly detection feature, which is carried out by BACS, right? And the BACS, as said, is the behavioral analysis and cognitive security component of the Cyrene platform that detected the anomalies in the IoT sensory data, such as the temperature raise or the mechanical shocks. And this is based on machine learning and deep learning algorithms. And the results from BACS are presented by SmartVits, which is the interface that we are showing and showcasing and demonstrating in this overall Cyrene demonstration. And the results from BACS are presented as a time series of measurement from an IoT data logger. And in order to check the behavior of the asset, we select one asset from the drop-down menu, yes, as shown by this screen, and we show only anomalous events that are specific for this asset. And by analyzing the chart, we can see some peaks, as you see in the graph, and these peaks represent the numbers of anomalies in a specific period. You see, and those peaks do not necessarily mean that the asset is the target of some threats, but it is an indicator, how to say, to raise the level of attention from the side of some security officers who may want to increase or decrease the level of criticality of that asset. Right. So the next function that we are seeing now is the intrusion detection system, which is carried out by the IDS FPGA tool. And this system detects any forbidden access to the CRF supply chain assets based on specific rules. And the IDS component has rules about all the valid IP addresses and the places, such as the resources, the machines that can be assessed by these IP addresses. And the attacker is not aware about the existence of this component, the IDS of these rules, and the attacker uses some valid credential to access to the supply chain system, as we have seen in the description of the scenario. And the fact the employee tries to intrude into a server that he should not have access anymore, and this is captured by the IDS FPGA module, which you see, yes, detected this intrusion as shown via SmartVits, where all the information about the IP addresses and network ports of violation are presented. As you can see, we show the intrusion from one server, which is the machine 2, to the front-end Linux server, which is the machine 1. And the intruder logins with his password normally without any problems, but the IDS FPGA detects this intrusion from the unauthorized IP address and sends the corresponding information to the Cyrene IO framework. And this IO framework shows exactly all this information as far as the IP addresses and the ports of the TCP network packets that activated the alerts are corresponding. And the number of the TCP messages that created the issue are also presented in the TCP data graph, as you can see. And let's just mention that the hour at the time is UTC time, which is 2 hours earlier than the Central Europe time. So the detection has occurred actually in real time anyway. And okay. Thank you, Petros. Now we move to the security and privacy assurance suite, which is based on Everest, right? And we describe Everest and the event captors. Okay. The Sphinx component, Everest, is a runtime monitoring engine that provides sophisticated event processing capabilities in a continuous manner. And Everest provides a model-based monitoring approach, allowing the user to tailor the monitoring rules to the organization's specific needs. And to capture the logs of a cyber system, Everest works with these event captors. And basically an event captor is a tool that, based on a specification set by Everest, this tool aggregates logs and event information from the target infrastructure and encapsulates into a specific format this information that will be consumed by the Everest model. And in this demonstration, as you are seeing, we created and deployed a monitoring rule that checks the status of a specific instance of a MongoDB service. And to accomplish this, we have also deployed an event captor that utilizes Elastic's Earthbet. And to check the output of Everest, we can navigate to the Cyrene dashboard. And as we see, Everest currently reports that MongoDB is viable by this satisfaction labeling, and in general, a violation, it was detected, the violation event that happened before, because the MongoDB was stopped and then restarted. And in general, a violation means that the rule that we are currently examining was violated, meaning that the service became unavailable. Okay. So finally, we move to the DVATS, which is the vulnerability assessment component, and we demonstrate the function of DVATS. DVATS, let me remind, stands for Dynamic Vulnerability Assessment and Testing Service. Okay, the security staff detects, analyzes, and assesses the vulnerabilities in their systems using this DVATS service. And DVATS is aimed at revealing the presence of vulnerabilities in the ICT systems and infrastructures of the supply chain. And DVATS achieved this purpose by means of two distinct vulnerability detection methods. There is a passive network-based approach and an active host-based one. And the results that are generated by DVATS can be found under the dynamic vulnerability tab of SmartFits. And the top section, if we move a little bit, thank you. The top section provides an overview of the detected assets, including their unique asset ID, the last seen timestamp, the IP addresses, the MAC addresses, and some host names. Okay, the second section into this view displays vulnerabilities discovered by DVATS passive detection. You see passive vulnerability analysis, and this is based on the captured network traffic, and in this case DVATS detected the use of an insecure NetBIOS name service and an insecure FTP server and also an insecure HTTP server, and each one of these vulnerabilities are assigned a unique identifier, as you see, with a description, a rule, score, and the indicator. And on the right of this table, there is a pie chart, as you see, which is highlighting that in this case, all detected vulnerabilities have received a score of medium, as you see. Okay, the last section. Could you please stop your microphone? Thank you. And the last section shows the vulnerabilities detected by the DVATS active detection. Okay, and thank you, Petros. Since these vulnerabilities are based on accurate software versioning information directly obtained by the host, DVATS can detect vulnerabilities based on common vulnerabilities and exposure that is the CVEs. And DVATS utilized these CVEs to detect vulnerabilities, enabling remediation information, detailed scoring, and linking of the vulnerabilities to known exploits. And the utilization of temporal parameters of the common vulnerabilities scoring system also allows for a more relevant score for the Cyrene end users. And the next stage is the vulnerability severity and attack scenarios generation. Right. And the risk assessment calculation takes as input the so-called attack scenarios, which is actually a triplet of asset, vulnerability, and threats. And to automatically generate all possible attack scenarios, the Cyrene platform requires two steps actually. Oops, we have an issue with our platform. I kindly ask yes to the guests to wait some moment until the technical team is facing this issue. Okay, we resumed. Okay. Okay, thank you, Petrus. It was quick indeed, and it is also useful to showcase that there is the resilience, of course, of our platform regarding how to say this
load balancer it work.
It
So
is interesting. It is interesting indeed. Okay, so thank you, Petrus. And so this stage that we were discussing is the vulnerability severity and the attack scenarios generation, and the risk assessment calculator takes an input, the so-called attack scenarios, which is actually, as we have said, a triplet of asset vulnerability and threats, and to automatically generate all possible attack scenarios, the Cyrene platform requires two steps, and the first combines assets with vulnerabilities based on the tools already presented. And also this step is really crucial because end users can explore and review the vulnerability metrics of the CVSS 3.1. And we can observe the autocomplete functionality under the environmental score metrics tab. And this is tested, yes, this is tested upon asset vulnerabilities, adjusted to illustrate the vulnerability severity regarding the supply chain service environment based on the Cyrene's RCA methodology. And for example, the supply chain assets presented previously, they have been considered of a very high criticality for the execution of the specific VTS process. And according to the RCA methodology, this corresponds to the levels I of confidentiality, integrity, as you see, and availability requirements, the CIA metrics fields of this environmental group, which stresses the respective attributes of the assets vulnerabilities as depicted. Okay, the second part of this step is to generate the actual attack scenarios. Okay. Okay, as you see, assets and vulnerabilities are joined with threats by performing some queries in the background, and this is indeed a purely background process. It produces thousands of records and takes some time. So we proceed to the following phase in our execution, which is the attack path simulation services. Okay, we are in the simulation environment, right? So to estimate the cascading effects to the supply chain service network in view of a cyber attack upon specified network assets, Cyrene CRF will use the Cyrene attack path simulation environment. This screen, this function which is showed under at this time, and in this environment we'll set an experiment basically to investigate alternative vulnerability chains that could be exploited by an attacker. Okay, so to investigate this, we simulate an attack from an asset entry point to an asset target point, and this allows to explore the attacker behavior and movement through the network. Okay. as we see here, it takes some time to generate, this simulation environment. A moment. Okay, got it. We can see here the list of the generated vulnerability chains for the current simulation, and at each vulnerability chain we have the exploitability levels, as we see: high, medium, high, very high, and so on. Which is namely, it is the possibility of an attacker to exploit the specific vulnerability chain calculated by Cyrene, and by clicking on a specific chain, as we have seen, we get this attack graph, which is showing the path that the attacker may follow between the selected asset entry point to reach the selected asset target point. And as we are seeing, yes, by clicking on an asset node of the attack graph, and we get in this way the security information of the specific asset, and for example the exploitability score, which is the possibility of exploiting a specific vulnerability on this asset. Okay, perfect. So the next step is the risk assessment. Actually, we proceed, right? And since all the prerequisites to calculate a risk assessment are now fulfilled, and that is the vulnerability assessment and the threat analysis have been carried out. So now the end user initiate a risk assessment upon the assets of the automotive components inbound logistic process of the vehicle transport system. And in the current risk assessment calculation, we also consider the attack potential metric, which is basic as agreed in the SVA. Okay. Now that we proceed, and in a moment, we see in a moment the executive summary. Okay, got it. The executive summary that has been requested by Petros is a report showing the risk level of the assessed supply chain service asset by means through analytics. As we are seeing, they are how to say, very low, very high, and so on. And in addition, there are at the bottom two bar charts that are presenting the threats with very high probability, meaning that these attacks can be easily executed, and they are detected for the assets of very high criticalities. Okay, do you see? Yes. And lastly, at the bottom right, we have this heat map, which is showing the impact level of the vulnerabilities along with the threat probability based on the attack scenario that has been provided as input. And keep in mind that we will re-execute a risk assessment afterwards based on different assumptions, and especially by updating the asset criticalities, and we'll see how these numbers will change. And we'll do this to investigate on how much, how to say, the risk is going to decrease. So we move to the next stage, which is the risk mitigation via controls, right? And obviously end users are able to mitigate, to take mitigation measures, and we call them controls in the Cyrene platform, that can eliminate vulnerabilities or threats. And for the today's demonstration, we have created two controls, one that mitigates threats and one that mitigates vulnerabilities. And overall, we present an executive report with high and comprehensive deltas that easily, how to say, explain these results. And in addition, we are going to update the criticality rules of the process under examination and its associated assets. And specifically, we set the process criticality, yes, as seen, to very low. Okay. And in order right, to explore the effect on the supply chain assets. Yes. The next phase, okay, moment. Yes, next phase is the new risk assessment that we start, and basically we will regenerate the asset profiles. Take a moment as you are seeing, okay, and then we will regenerate also the attack scenarios. Yes. And then we re-execute the risk assessment. Okay. Okay, then now to conduct the new risk assessment, which will consider these assets updates, we follow the same procedure, the same step that we carried out before in the Cyrene platform. And so, while creating the new risk assessment, the only alteration is to select the risk assessment type, which is now real, as you see, right? And this in this way we consider the usage of actual controls on specific assets. And okay. Here we have the executive summary, as you are seeing, and this is the executive report that has been produced and which is now completely different. And the risk, yes, the risk has been dramatically reduced after enforcing these controls that we have put into operation. Great. So finally, as a very last phase in our long execution session, to say we have the generation of the overall Cyrene report, and as you see, that report aggregates and combines results from all the Cyrene components, and specifically the Cyrene overall report highlights the risk assessment results of the supply chain service assets and the respective mitigation measures that are implemented. And in the current report, we can also see the conformance claims aligned with the Cyrene cybersecurity certification scheme presented in the RCA methodology session by Elma. And such information is, for instance, the assurance level, the vulnerability analysis level, as you see, yes, AVA 2, and the attack potential. And the overall Cyrene report aims to advise, how to say, the business partners involved in the current risk assessment to develop the protection profile of the supply chain service based on common criteria. And to this aim, by exploiting the assessment results and the implemented mitigation actions, all business partners, they elaborate and mutually agree upon a set of security and assurance requirements. And as a further step, the developed protection profile can be communicated to the security auditors to conduct a conformity assessment as already presented into the RCA methodology session. And this helps to examine whether the current supply chain service is subject to a cybersecurity certification. Okay, that was the end of the execution of the Cyrene platform on our CRF pilot, and this concludes our demonstration. I would like to leave the chair to Spiros Fotis, who is our manager of the dissemination and communication activities, for the question and answers, if you have any. Spiros, the floor is yours.
Thank you, Julio. Thank you to all the partners for the insightful presentations today and for the demonstration of the pilot, which was very, very analytic and provided also much insightful information for the pilot itself. It was really interesting to watch, and as we earlier, before we started the presentations, we added in the chat box the guidance to all the attendees that they can post their questions on the chat box in case you have some questions. But now, since we are on the round table for questions and answers, if you have any questions, please feel free to raise your hand and ask anything you like. Our partners and our technical contributors will be more than happy to provide with an answer and explain further things in case something has missed your understanding. So please feel free to ask any questions. I don't see any raised hands, or perhaps any questions on the chat box. Until you do so, let me just add in the chat box the questionnaire for the validation of the pilot, because your feedback is always valuable to us. So let me just paste the questionnaire here. Feel free to visit this link and provide your feedback regarding what you saw today. It always helps us to improve the Cyrene, the platform, I mean, our solution. Your feedback is always valuable, especially if you are in the industry and you know the needs, you know the risks, you know the problems. So your insight is much of help to us. I don't know if you have any other questions or any comments, guys. Also, comments are also more than welcome. Share your thoughts, any of the partners or the attendees.
Oh, there is a comment from Leila Godbani. Hi, Leila.
Yes, hi, Leila. Leila thinks that this is the future, and she wants to know if there is a launch planned for all the industries. You mean, Leila?
Yes, exactly. I think that this is the future, but my opinion, and I think to ensure a seamless supply chain, smooth flow of containers, which are become more high valuable. Even the container itself is high valuable, as well as the part it is. So is there a project planet? And is there maybe a collaboration planet? What is currently existing in the OEM, and how to connect this with each other, how to set up really a launch or a pilot study, since there are some projects ongoing in the company, as I know, and but how to connect these projects with each other and really to make such a launch a synchronized launch. I hope you understand my question.
Yes. Should perhaps our project coordinator, Sophocles, answer this question, or
I think
if
I
there-
can
Yes.
handle this question. Thank you,
Thank you,
Leila.
Sophia.
Well, if this has platform-specific enumeration, can be automatically linked back with some open repositories from NIST and MITRE that we already use, this is fine. This can be automatically performed, but in parallel, and a step that was not demonstrated because this demo was had a lot of detail. We also provide the functionality to model by our own these OMs. So the end user can define its own if this is not part of an ICT digital asset that can be linked back with some well-known schemas, I would say, well-known ontologies, and can assign giving some descriptions and some specifications its own assets. Okay. Also assigning a value in order to quantify its criticality. So this is currently being handled automatically from the Cyrene platform, provided that this OM is well known, something that can be found as a means of a digital ICT asset. Otherwise, this can be done in a semi-automatic manner, letting the end user populate her own OMs.
Great, thank you, Sophia.
So I understand there is a customization possible, but there will be an investigation need to be done how to connect this, or how to, let me say, to synchronize, how to make the synchronization. But this could be handled an extra call to align and investigate and analyze, right? That's what I understand, at least.
Right.
Totally.
Thank you. Thank you. That's all. Thank you very much. And thank you for this really very good presentation, all to you.
It has been a pleasure, Leila, that you had the possibility to join this demonstration. Thank you.
Thank you, Leila. Any other comments or questions that you may have?
Sophocles?
Yes,
Yes,
hello from my side, and thank you from me as well on this very insightful demonstration of the technologies that have been developed in the project and how they have been put in use. Sophia, of course, covered the previous question. From my side, Giulio, as an end user and let's say user of the Cyrene technologies, maybe you can summarize overall experience and any comments on the actual use, because you have put the Cyrene methodology and the platform in actual use in your pilot case, that interesting scenario that we discussed. If you have any, let's say, first comments, right, and feedback on the use of the technology, that would be glad to hear.
Sure. Indeed, Sophocles, we had how to say to take this commitment as a project partner first of all, but as an user, obviously it was a really complex exercise we had to face to adopt the whole how to say into all part the complexity of the approach, which is indeed it turned out how to say as a very strong how to say type of and appealing also for the end users and the industries in general. The point, Sophocles, is that end users mostly they look to the a simple question to answer such complex questions. A simple another let's say point mark, which is okay. the activities are complex. The end user should invest for bringing new concepts, new technologies, and new achievements and new methodology. Where is the value and where is the business case? And then I'm very glad to report to you specifically, so to you, Sophocles, but to you all in this session, to all the participants. We are very glad to testimoniate that we very easily found, and since the beginning we found a way for justifying and supporting the extra costs that need to be put, how to say, into this work, into this exercise, and this really justifies the time, the work, the resources that end user should put on this. Specifically, the risk, the RCA methodology is in its even in its definition, it's a conformity. It's a conformity methodology, and it is a conformity assessment. And this assessment of conformity allows to really to sustain and to gain relevant resources and to gain some costs, to recover some costs from the side of end users. I just want to mention one of these point, which is quite important, but just to explain with very simple statements and simple words why the Cyrene platform allows really to recover some costs, is that in our current exercise, in our supply chain, the actual supply chain of the electric vehicle batteries, we have the Samsung SDI factory, which is providing delicate components. These components, they will travel along all the Europe, and they arrive into the assembly in Mirafiori plant. You should be probably not surprised to know that these components will be, let's say, tested, qualified, and certified at the exit of the Samsung plant. But you should be surprised to know that also, as soon as they arrive into the Mirafiori assembly plant, they again are checked, tested, qualified, and re-evaluated. So this duplicated is solely and only due currently, so in the current approach, to the fact that there is not an available certification schema and approach, which is ensuring and guaranteeing that the components along all of their delivery, that they were not subject to cyber threats, vulnerabilities, attacks, and compromisions of their quality. So in order to check the quality again, this duplicated effort and work is actually carried out. Easy to recover money if you make the certification and the quality assessment at the exit of the plant, and if you take this conformity assessment declaration from this actor of the supply chain, there is absolutely no means to repeat this work, and we can recover a significant manpower on this exercise. This is our business case. We would like really to use and to adopt Cyrene for the future. It is just our let's say punctual example in the automotive industries, but Cyrene will by sure find similar exploitation opportunities in other domains and in other industries. Sophocles, I hope I replied to your question properly.
Yes, very much, and more than so. Yes, thank you very much for this detailed explanation. Very glad to hear that the solution technologies and the methodology of the project, right, is so useful, and there is so much willing to be picked up by end users like CRF. So this is good news. This is very good news. Okay, so thank you, Giulio. But a follow-up question, if there are no other anyone else to ask, is that CRF of course was a very valued partner of the Cyrene consortium. So you followed also parts of the technical work. If you put yourself into a position of a supply chain stakeholder that wants to make the self-assessment, the application of the methodology on their own part of their supply chain, right? So we heard before that these methodologies of dual use. Do you think some support and training services would be necessary, or how do you think that you could take the step of self-assessing your...
Yes, it's a problem indeed, but look, Sophocles, it happens for whatever new technologies or new methodologies as it is the case to fall in the need to sustain expenses and costs for training, for making people aware and about the proper way to use the platform. But however, I speak about Stellantis, which is the domain that I know, and we have a very robust, how to say, ICT departments who, let's say, should sustain directly these type of process and procedures, and clearly some training should be needed. But come on, technology is progressing. We all move our industrial sectors into making how to say more and more our work towards the digitalization and usage of sophisticated tool and instruments in our work in our work of every day. So I don't see that this is how to say a breaking issue, the one that you are posing.
Okay, thanks.
Thank you both. Thank you, Sophocles. Thank you, Giulio, for this interesting exchange of information and dialogue. But before we end this session, for the dissemination purposes, I would kindly ask all participants, if possible, to open their cameras, and in order to have a very nice screenshot with everybody that we could use in our website to spread the news. So if possible, also let's stop sharing the screen in order to fill the screen with these most familiar faces and many people who helped this event to come to completion. So let's wait a few minutes for everybody to share their cameras, and let's say the traditional would say in these cases. So please say cheese, and let's have a few screenshots.
So, cheers. It's very nice indeed.
Thank you all. Giulio, the floor is yours to close the event.
Yes. No, it is very, very short. I would like really to thank you all. Thank you all. The guest, we will have the time to thank you, the internal partners of Cyrene in the oncoming days. But for the guests and the participants, I would like really to thank you for the time, and we will try, and as commented by Spiros, to stay in touch also with you. And I see Gianfranco, hi, and many other guests, friends and colleagues who have been involved into this event. We'll share our questionnaire, and we'll be very happy of staying in touch with you.